assistant at University Polytechnica of Bucharest and a machine learning engineer at Infineon Technologies. First of all, I would like to congratulate for the decision to attend this conference. I also encourage you to take advantage of today's presentations and ask all the questions that you may have. Now, the 13th edition of TechTalks Online brings together IT professionals, passion for technology, local and international speakers, as well as great companies. Today, there were 3 conferences prepared for you. This is our last one, Java. Also, your feedback is very important. Therefore, at the end of the conference, please complete it. It will appear a form right above on the top of the screen. Also, at the same time, you can ask questions to today's speakers through the microphone or to the chat during the Q&A sessions. If you wish to use the microphone, please raise your hand from the chat and you will gain access from the organizers. One last administrative aspect, the event will be recorded and some keynotes will be shared live on Facebook. Now let's start with our third and last conference. It's about Java and our first keynote, Master Your Weapon after 30 years of Eclipse, why did I switch to IntelliJ, will be held by Victor Rentea, one of the 2 Java champions in Romania. Victor is an associate professor at University Polytechnica of Bucharest, and this spring he gave up his job as a lead architect at IBM, and he now works as an independent trainer teaching and consulting developers in dozens of companies every day throughout Europe. He's an official maniac about clean code and testing, and he's going to share his passion with us in his session. Victor, the floor is yours.
Thank you, Andrea. So, indeed, it's a hot topic. Let me first add some words about me. As Andrea told you, I am one of the 2 Java champions in Romania. 14 years of Java, plus other languages. I spoke a lot in many conferences. I also have I gathered up an entire playlist on YouTube that you can watch with my best talks. You can access there in this link. I also founded the community, which is today one of the largest community in one of the largest developer communities in Romania. More than 1,600 developers are there. The purpose of this community is to share my passion about simple design, refactoring, and testing. So do join this if you want to access some free monthly webinars that I'm holding. Next one is next week, by the way. I think Tuesday, if I'm not mistaken. So what I'm doing, I'm coding and speaking, live coding 1 hour per month in approximately. So do join if you like. My activity basically is for over the past 8 years, I've been teaching a lot of people in many companies, a lot of speaking. My main area is, of course, Java. I must add, Java is the last day, but certainly not the least day. I mean, Java, come on, it's the most used language in the world today. So Spring, Hibernate, functional programming with Java, design patterns, domain-driven design, clean code. That's why I'm really interested in the next talk after mine, cleaner code. Unit testing, test-driven development, performance, Elix, Java, Scala, a lot of stuff that I'm doing in many companies. If you want to check out my website for the full agenda, it's there. If you want to follow me, please do so. I'm posting funny and interesting stuff I'm trying at least every week. Now, if in case you would like what will happen today, if you want something, some trainings from my curricula for your company, this is the website. In case you wanted to join individually a webinar, this is my Teachable account. You can check for live webinars. The next one is next week, I think, on Wednesday, if I'm not mistaken. I'd like to start by bringing up a memory. Some of you should have this memory. When you first drove a car without the instructor next to you. Remember that day? Imagine you got on your car, okay? The first day without the instructor. Oh my God. You took with you 3 spare t-shirts and a pair of pants. Brown pants. And then you grab the steering wheel and okay, let's go. Oh, first of all, the seatbelt. Oh my God, the seatbelt. Let's arrange the mirrors. Remember, arranging the mirrors. Yes. Then turn the signal. Then let's look. No car comes, and then you enter the road. Okay, good. And the first intersection is a red light. Red light. How good. Time to relax. Good. Then you have to turn left. Remember the first time you turned left, right? The first time you turned left in a big intersection, right? I was like completely wet down to my in the middle of the intersection. When the tram comes this way, the bus comes this way, and the big one comes from the backside. Then in the middle of the intersection, your girlfriend turns on the radio. Oh my God. It's like the end, you know? You just snap. It's just too much. It's just that bit of stuff that is just too much. Okay? Remember when you first started driving, remember how you looked at the turometer to see the number of rotations you had until you shift gears? Remember when you looked at the gear shifter? Oh my God, in what gear am I? Oh my God, right? This is you during the first month, the first year, let's say. Good, then let's turn time forward 10 years. Then do you ever look at this anymore? Maybe one per week, maybe. If you are wearing headphones. Today we're just listening to the car. Okay, we shift gears. If we ever have a gear shifter anymore, right? Then, so after 10 years, you're driving relaxed. You can turn on air conditioning, change the radio station, no stress at all. All while keeping very much attention to the road at the same time. What changed? What has changed? But first of all, you know your car, right? And this is the purpose of today: to learn your car, to learn your editor, to learn IntelliJ. Secondly, you will be more attentive to the road because you know where the dangers are. You know where typical stuff can hit you, right? We know where typical dangers arise. So first of all, you need to master your car. You need to learn to listen to your car, and that's the purpose for today. After 13 years, why did I switch to IntelliJ? Oh my God, it hurt. It hurt for 6 months. It hurt. And by the way, I'm not using the key map from the Eclipse. I'm using the IntelliJ key map. And I wanted to talk with you about this because since I'm training in many companies, I've seen 30% of developers with Eclipse for some deployment reasons, for some because they are deploying on WebLogic. And indeed, the integration in Eclipse with application servers is way better than IntelliJ's, that I will admit. But as they move to Spring Boot or other frameworks that don't require an application server and deploying to that, they still have a hard time changing the IDE, right? And I know that because I've talked with hundreds of developers just during the past several months. So let's see what I will focus today on the things which are. I wouldn't try to convince you to switch to IntelliJ. My purpose is to show you why, or maybe some things that can be done better in IntelliJ. First of all, let's imagine you want to build an array of, a list of integers. So in Eclipse, you will start with list of and then type. Now, let's see how we will do this. First of all, you want to use asList. You don't have Java 10 or something. You just Java 8. And asList, you know that there is a method asList somewhere there. So what do? You press Control Space once more. And suddenly you get the static import suggested for you. You just hit enter, and there you go. Basically, it found the static method for you everywhere, right? Let's see another one. Let's see. Random. There is a math random. So there you go. Control space twice, nothing. Once, nothing. Control space twice. There you go. Math random. So coming back, as list, control space once, and there you go. The second time you press, you get the suggestion. But what did I do? Let me move slow. I typed 1, 2, 3, 4, and then right now, Control Shift Enter. Control Shift Enter will finish my statement. You notice how it put the white spaces. Very nice, right? Plus finished the statement, right? Right now, you will probably want to put this listener into a variable. What would you do typically? You would start list and say integer m. Oh my God, don't ever do this. In Eclipse, there is a very fast way of doing this. It's Control 2 and then L. But in IntelliJ, Alt Enter. What would you do if you call a method that returns you something? What should you? I mean, it's obvious, right? You want to put it in a variable. There you go. So Alt Enter Enter. Alt Enter Enter. It gets you the variable, right? let's say numbers. Eclipse also has this control 1 enter. But the point is you get the list of as a variable. Very good. Now, let's move on. One thing that you do very often on a list of something, you iterate over them, right? But the human mind goes like this. I have a list and I want to iterate over that. That's the normal train of thought in every person's mind. So there you go. You say, on the numbers, I want to do a 4. Now, what the heck? What 4? There is no 4. But there you go. If you press enter, oh, what the heck is this? Let's do it again. So you just do 4. And this is called postfix template. Postfix template. It means that you're starting an expression, and then this one you want to iterate over it, or you want to S out. Very good. But typically, you don't just do this. Let me put the 4 here for you, and then let's pretend that you want to log debug the number, right? You already foresee that you can type this, right? This is simple. I just showed you that. But I want, just for fun, to define a custom postfix template, which would allow me which should expand to something like log.debug of number. We do this all the time, right? You get an expression, and then of course, I need a log. But where do I get the log from? And I don't want to do this. No matter how I would like to do that, there are people among you who don't like Lombok that much, who are not a big fan of hidden fields which are generated, because this is what it does really. If you look at them in the bytecode, who the heck looks in the bytecode? But anyway, if you look at the bytecode, you will actually see, I hope somewhere. It's not visible yet here, but there is a hidden. You can press Control F12, for example. Control F12, just come on. It's just refreshing. Control F12, it shows you the members of this class. And there you go, there is a log field, although you don't see it, right? But again, I don't want to talk about Lombok today. So that's why I would like to stick with the classic one, which starts like this. Let's see. Well, logger factory, okay, dot get log. I need to put this first in the method. Wait a second. And then dot get logger of this class, IntelliJ play dot class. Now, another thing that you can write here, EGP, you all know that expands to this is also in Eclipse. But something is interesting. You can put here EGP expands to class dot class. Very good. Now, Alt enter, what will give me right now? Imagine, so first of all, it's missing the semicolon, you see? There is no semicolon there. Now, Alt enter will introduce a local variable in front of this line, but it will also close the statement with a semicolon. There you go. Super convenient. So you just need to type the expression that you want to run, and then you get the local variable by super fast. Right? Let's make it log, and let's name it. Let's move it out of this method, and let's make it private static final. Static. Good. This is the line that you will be typing over and over again. Now, log debug number. Now, this doesn't compile because you still need to put something here, number like this. Let's try to start over. What if you would type this S out? Would this work? Yes, it works. But now, I don't want this. I want log.debug. Now, I want, first of all, to define a postfix template, which will allow me to type, let's first type something easy, .log. And when I press then Control space, it should expand to this. So how would we do this? Let's go to settings. Let's type postfix completion, and in Java, I will create a new one in Java, which is something like log. Plain old Java is good. And then I think that's good. This is good. And let's see. Well, log.debug. The keyword is you should refer to expression, which is the thing which comes up before typing log. Let's see if I get it right. Let's see. So a.log, control space, there you go, enter, excellent. You saw? Now let's try the more complex one, plus number.log. Would it work? Yes. So what did I do? I just type log and then control space, because this is how you normally think, right? You want to first you engineer the expression to write and then log it to poof, log. So very, very, very good. This is the postfix template. No worries, there will be a summary at the end, so just relax for now. Now, about this line, could I make it shorter? Could I make it? Could I have the could I have IntelliJ completed for me? Let's start over just a bit. I want to now be able to go here and maybe log for XLF4J, log C. I want to create a, I want to press Control Space now, and that thing should expand to the line that I just cut from the code. So there you go. Again, back to the settings, live templates. I will show the best things which are there. Some of them, I admit, they are also in Eclipse, but I will get to. I will highlight every time there's something which is completely live template. Good. Logs, very good. And then this is a template. And now here, this shouldn't be always IntelliJ play, right? So what should I do here? So I put a variable, class name. Let's say a variable. All right. Now, if I edit the variable, class name can be. Let's see if I make it. Class name. There you go. Class name. Skip if defined. Okay. And then where could you put it? What is it applicable? Let's see a declaration, for example. Let's see if I get it right. Logs. There you go. But this is not yet imported, you see? So what would I do then? Well, I could rely on the importing, but I don't want to be doing this every time. So that's why I will do the following trick. I will define the full expression like this, exactly like this. Go back to the settings, replace this with a fully qualified name, and then check this one. Shorten, it's already checked. Shorten fully qualified names. There you go. Okay. Then what would you get? Well, log C, enter. Done. You see? No matter what class are you in, let's say class A. There you go. You want the log? There you go. A.class. So it's like a template which takes into account the context in which you are using it. Very good. This is called live templates. So I've showed you postfix expansion, which is something that Eclipse doesn't have. I showed you the .4, which is something Eclipse doesn't have. I showed you then live template, which there are equivalents in Eclipse. Let's see. 13 years of Eclipse. Can you imagine? 13 years. Let's try to get a date 1 year ago. So 1 year ago from today, I want to get it in a variable. How would you type this? Well, let's start with the full stuff. Probably local date 1 year ago. If you forgot to import, just Alt-Enter when you pause, it will import it automatically. Equal local date. You know how to press this. Oh my God, this is a plugin. It's called Codota. I think it's also in Eclipse. It suggests the possible continuations of the things that you. But one thing that I love very, 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 very much in IntelliJ is that I don't have to press Control Space every time. In Eclipse, I was just killing my space keys, push, control space. Yeah, it was like Pacanelli. It's like playing how do you call this? Slot machine. Control space. Come on, folks. Of course, I want to complete it. Local date. Now, this is easy to do, but I want to show you something new. LD now. Without Codota. What the heck is this, my friends? It's like, whoa. It's like expanding over a dot? What the heck is this? Let's start over again. So local date now, it expands the expression even though there is a dot in between. It doesn't work if you put another dot, minus. It wouldn't expand like this. But with one dot, you can, because you typically, especially in an enterprise application, classes have long names, but you typically refer to them by the capital letters. This is one of the first things you learn when you get hired as a developer in an enterprise application, is that the classes have long names. But you get over this by using the uppercase for the words. Okay? Local date now, however, it allows you to skip. Right? And then right now, Alt-Enter, enter. what will happen? I'll enter this suggestion, introduce local variable, which will put a semicolon for me and define the variable. There you go. Just quick check because today I'm on. Yes, excellent. Good. Great. Now, how would you do it 1 year before? Well, minus, of course, minus years. Notice what I type very carefully. Look very carefully at the colors. Minus years. Very good. So I'm just typing without, in Eclipse, you also have this, but you have to put a shift Y. Okay, Eclipse requires you to do this. In IntelliJ, no, it kind of understands that you want to type the letters, you see, which is very, very, very convenient in real cases. Very convenient. Excellent. So I got the 1 year. I created the log field. Yes, I've created the postfix template. Thank you. Good. Now, let's see another example, which is very, very interesting. In many cases, I used it. Let's say you are opening a resource which needs to be closed. Let's make it a file. So new. Let me show another one. File reader. Okay, up until now it's clear. But what the heck does it mean to put .new? There is another postfix expansion. Okay, I don't use it this much, but look what happens. Okay. Good. And then asks for the file, new file, a.txt. I don't care, just a file, just for the sake of. Okay. Now, when you pause, it will suggest to alt-enter import stuff. So alt-enter chose the import to do. Thank you. And now this stuff, alt-enter now introduce local variable. Notice where my cursor is, for Christ's sake. It's in the middle of the expression, right? Alt-enter, poof. It put the semicolon and define the variable, allowing you to reader. There you go. And then this requires that it throws an exception. Oh my God. Let's first throw it away. So you can use the mouse, by the way, right? Click. Mouse driven. Yes. Excellent. And it throw the exception away. Good. But let's see. Reader.read. I don't know. Read what? Read. Ugly. Read the char, really? Read the char? Oh my God, who does that? But anyway, this read will throw again. There you go, let's throw it again. And our exception there. Now, the fun part that I want to show you is when you alt-enter on the reader, and with big eyes, please read the first suggestion. My friend, would you like to close the file after you've finished using it? And I will say, oh, you're right. So there you go, alt-enter, enter. Look at what he did. Just again, slow. Alt-enter. And 3, 2, 1, try with, and then reader.read. Very good. So it somehow, whenever you are defining a variable that of a type which extends auto-closable, what the heck is auto-closable? Or this one, closable. At that moment, IntelliJ will suggest you to open a try with resources, right? Even if you're streaming over, like for example, files.lines. Let's just type the least amount of file.line. Oh my God, how lazy can it be, right? And then new file of a.txt. Good. Dot. Guess what? 2 paths. What could you say here? There you go. And then alt-enter, enter defines a stream of lines, of strings, which, interesting enough, is also a closable resource, because stream can also be closed in case you are opening it from a resource which is closable, like a file system file, right? And then you can use the lines as you could. Oh, nice. This is called .dot. I'm cheating. This is not just IntelliJ, it's artificial intelligence completion. So I will stop, but we get the point, right? I'll enter on the closable stuff. It will just try with resources. Very good. Now, yes. Let's see. I had some other things I want to show you. So let's check from what I've showed you until now. I've showed you how to complete statics. Yes. I've showed you how to, yes, somehow, but not the entire stuff. Control Shift Enter. I didn't show you that yet. Let's try. We try to compare. This is not now, right? This is 1 year ago. Now, let's try to write a stupid expression. If 1 year ago, we can be very lazy, right? Is after, of course, is after. But now, I wanted to show, to look very careful about the colors. How to put this? Do you see that my cursor? Let me check right now. Do you see where my cursor is? It was it disappeared. Let's try again. And please. Now my cursor is there. Let's try to select this suggestion. Then, are you also annoyed about this A here? Again, undo. 1 year ago. If you press enter, you get shit. You get garbage after your expression. If you press, however, tab, what? Tab, yes, my friends, tab. Tab will override the current symbol with the suggestion. Very interesting, tab. So tab will just override, this is tab. Tab, it overrides the symbol that you were on with the thing that you want to complete. Very convenient in real cases in case you want to switch is equal with is after. There you go, tab. Again, I'm here, I want this before. If I press enter, garbage. If I press tab, peace. Then, my friends, harmony. Excellent. You get peace of mind, right? Every time you are in the middle of a symbol and you are not entirely sure what you tab. Excellent. So, showed you tab. But now, what is after now? Guess what? Of course, it's that now. But this is impossible in Eclipse. You should write local date, maybe control space there, and then now. This is by far, way, enter. And now, look where my cursor is again. So these guys in JetBrains, they really tried to make us extremely lazy. In Eclipse, you would right click, right, open the bracket, enter. My God, there were 4 keystrokes. No, I was there. Now, what am I trying to do? Tell me. I'm trying to write an if. Control Shift Enter. By the way, I'm using Windows keys here. There are equivalents for Mac, of course. Control Shift Enter will finish the current statement, but in case the current statement is not yet closed, for example, my if here, my God, it could be here. Control Shift Enter in 3, 2, 1. Incredible. It puts the, it's just the good. It's just the good. And my cursor is there. Excellent. So Control Shift Enter again. In case you are trying to iterate over the numbers. Numbers 4. Control Shift Enter. Could it be like that? No, my God. No, but this was easy, right? Let's try to write a try, maybe. Yeah, try. It's a good one. A try. Yeah, a try. Shift Enter. There you go. All right. The most interesting one with Control Shift Enter is when you write an if. To be honest, that's the best thing. So just write the if, put the expression in there again. If 1 year ago is before now, Control Shift Enter, there you go. And you are relaxed. You don't need to put spaces. Oh my God, no. Just stick on doing your job. Very good. Control Shift Enter. Over dot expansion, I showed you. Local, this expanded to local date time, actually, if you put the T. Very good. Showed you that. Type safe auto completion. This is tricky a bit. Let's try to define a class. Person. Control Shift Enter, of course. There you go. Again, Control Shift Enter. Yes. And then private string name. Of course, as in Eclipse, if you type get name, you just want your get name. There you go. Enter. Peace, my friend. You want a setter. Set name. Perfect. And guess what? My setter is fluent. Why is it fluent? Because I chose it to be like that. When I generated last time a getter and a setter, you are used to doing this, right? There is the little combo box. No one noticed this. There is in the IntelliJ default, we just get to the setter, and there is the builder style setter, which generates a setter which returns this at the end. Very, very interesting. You can get rid of your builders in your system if you in your code base. We actually got rid of the builder pattern in our code 1 year ago. So you want to set that, my friends. Set n. There you go. Look at what's blue, right? Set n And then without any control space, just enter, and there you go. But now, let's suppose you have a person, new, alt enter, there you go, it's a person. And then you want to get the name out of it, name equal. Okay, that's too much. What the heck was that? Well, yeah, that's also very easy, right? Because it's figured out. But in case you have a lot of, how to put this? Just look, so Control-Shift-Enter. Control-Shift-Enter, it's called type safe autocomplete. Control space, you all know how to press. Control-Shift-Space. Control-Shift-Space suggests in this place all the expressions that you could write that get you a string. Why a string? Because you said you wanted a string. And there you go. Control-Shift-Space. Now, if you press again Control-Shift-Space, it doesn't work here. Doesn't work here, but if you would, let's say, date. Who the heck uses date anymore? But anyway, date equal. Yes, deal. Control-Shift-Space once, Control-Shift-Space twice. It gets you the static imports, the static methods out there everywhere that get you a date, right? Now, coming back, my name equal, and you say person, dot, actually you can directly press Control-Shift-Space. Nice. There's more than that, really. If you are very interested in, you can write something like this in case you have another class like address. Address. And what should I press here? Control-Shift-Enter, of course, and which has a private string city, for example, and I only the getter get city. Sorry. City, excellent. And then person dot Control-Shift-Space once, Control-Shift-Space twice. Oh my God, now what the heck is this? It navigated the model. It said, okay, you want to start with the person. So be it. Should I go to the address get city? Of course, it's missing a getter for the address, to be honest. Now let's try again. And there you go. Control-Shift-Space. There you go. Control-Shift-Space twice, get you to this. This is what you were after. Enter. Perfect. So for the conversion between data model objects, very good. Now, chain of getters, I showed you that just now. Live templates, we've created our own. Postfix was that thing with .log or .for, very, very useful. Or .if, by the way. Look, for example, if lines, that's a bad example, but numbers is empty, .if. So super cool. That's a super cool feature, postfix expansion. Very good. Surround with, it's also in Eclipse. It's a bit boring, but just to show you, you get the piece of stuff that you want to execute only within an if. Control-Alt-T, surround with if. Again, you just take this stuff, T, if. But that's also an Eclipse, so it's not such a big deal. I want to focus on the differences. Now, Control-E. I have a friend, Christian Zamfir, who was sitting next to me and kept annoying me by not using his mouse. Can we imagine how sad I was? I'm an old guy, and I'm like my mouse. I have a relationship with my mouse. It's like, oh my dear. But that guy, no. He just put the mouse like that and said, ha, ha, ha. And coded faster than me. How the heck did he do it? Control-E. You want to go to the poem? There you go. With approximately in 5 or 3 to 4 keystrokes, you find everything that you want. Very fast. Control-E is like a control tab, but in which you can search. So you want to go to, I don't know, utils versus, there you go, a class that you changed, or to the class person. The person I didn't, it's not a file. Very easy, Control-E, super cool. So this will allow you basically to not use the tabs anymore. That's the effect, really. You can just basically move so many params will. Control-E, many params. In 3 keystrokes, you find it. Very, very good. Multi-cursor, that's by far my favorite feature in IntelliJ. For example, but how to put this in a simple way? Yeah, let's go for a more complex. Why are you red, my friend? Duplicate class. Oh, I mistyped it. What? How to fix? Oh my God. And fixed. Oh, let me prove the feature that I want here. No, the perfect example. So I have this class. Now, this token appears in 3 places. Now, in Eclipse, what I used to do is press Ctrl K, kappa, K, many times to find the next token and then wrote over. This, in case I didn't want to use find replace, which is risky. In IntelliJ, you can do one of the other stuff. If you select the proper token, Alt J. Okay, do you see 3 cursors blinking, my friends? Whoa, mama, 3 cursors. Okay, how productive. Yes. Okay, very good feature. Now, I just wanted to put a 2 after that. Okay, but this is what is a bit silly, an improvised example. Let's get to a more, let's see if I can, not video, it's called customer. In case you want to convert from, where are you? Customer from video horror, excellent. Nope, not this one, in the movie class. I have an example of constants. You want to convert this into an enum. How would you do it? Of course, you all know how to put enum and start, I don't know, movie type and then stuff. But could you do it faster? Well, let's move this line up. This is by far the most dangerous refactoring in the world. And then look at the following stuff. I can select the token that I want to change everywhere. Alt J. I could have had dozens of lines. Backspace. And, oh my God. No, that's too good. Oh my God, right? Home. This is super cool. Alt J multi-cursor, by far my favorite feature in IntelliJ, especially useful in non-structured file. Like, I don't know, CSS, JavaScript, it's a bazooka array. This is super effective. If you master this, you can be 2 times more productive. Super powerful feature. By far, this is why I literally changed to IntelliJ. This was the trigger for me. Just too good stuff. In large projects, it's amazing. Control space plus, I showed you the tab. When you override something. For example, you don't want the city anymore, but you want the street name. For example, you want to get street name, of course, enter. Come on, there you go. And then here, you don't want to get the city out of it, but you get the, and now, if you press enter, garbage. If you press tab, love, my friend. It's better, ugly hard. Let's try again, love. So tab, you get Zen, my friends, Zen. Okay, like, I don't know, like peaceful and excellent. Good, what do I want to show you? Alt Enter, of course, Alt Enter is the equivalent for Control 1, but just 2 times better. Not 10 times better, but 2 times better. I also wrote a poem to this. If you don't know my poem, I should show you now for sure. When it's red, yellow, blue, or gray, Alt Enter will save your day. Of course, notice that I'm politically correct here. I'm also referencing other editors. But every time you see something highlighted or with a strange color in IntelliJ, you just don't think. You just press Alt-Enter, and then you think and choose the right stuff. Good. Define variable. I show you how to define a variable with Alt-Enter. Try with resources. I show you that. Unmodifiable. That's just got it. Move variable, it's too much. Extract expression, nah. Control click, another really good and comfortable feature. If you control click on token in IntelliJ, it will get you to the definition of that thing, as in Eclipse. But unlike Eclipse, if you control click again on it, it will show you all the places where this is being used. Like a find references, like Control-Shift-G in Eclipse, find references of token. If there are many places where this is being invoked, like this example right now, then it will list you all the places. For example, look, there you go. Right? Very, very comfortable in large projects. Excellent, good. Control-click. Didn't have time for that. And the best feature, of course, maybe you have noticed it, is this. By far, of course, this incredible looking This is the best feature. The best feature of all is this Nyan-Cat plugin. Okay. And my time is up. Folks, this is what we've covered, and I strongly advise you switch to IntelliJ. By the way, all the things that I showed you today, everything is free. It's free. It's community edition. Nyan-Cat. It's community edition IntelliJ. I didn't show you any feature of the ultimate edition. On purpose, because typically when we Eclipse, which is free, if you switch to IntelliJ, the first question is, where do I get the money from? You don't need the money. It's just community edition, everything that I showed you now. That being said, in case you liked it, don't forget that I have stuff for you in case you want you for your company or for yourself. And I hope to see you on another talk. And the next one for me is on Tuesday, I think. It's publicly stuff. Just join the group, the Bucharest Software Craftsmanship community. We also accept non-Romanian speakers recently. That being said, in case there are any questions, I forgot to stop at the right time, but in case, if there were any questions, this is the link.
Thank you very much, Victor. It was really one of the most engaging presentations I took part in. And I think the audience has some questions. At least they had some hints for you during the presentations.
Cool. Never used it. Okay, makes sense. Unwrap. Good.
Okay, someone is asking you to bring up the summary page again.
The summary page again. Yes, of course. Mm-hmm. But the problem, I don't have two monitors, but let's stick for this. And you know what I'll do? I will, in order to see the questions also, I will do the following stuff. Excellent. And then here, and there are the questions. Excellent. Any other ideas here? Let me check. Control 3, yes, Control 3 is good, but it's not that good as Control E. Try it in the video store. Yeah, remember you recognize it. Enter or Control Enter on completion in Eclipse switch between insert and override. I did not know that after 13 years. Thank you, Mikhail. I will try this right after the meeting. Thank you very much. I will actually paste this here. Very good. Good. Other stuff. Let's see. Other questions? Are there any other questions? Yes.
Yeah, some people are writing something now. So let's wait.
Okay. Good. Alt Enter Driven. Christy, are you here? Yeah, thank you. Christy is here. I told you about him. Option Enter. I think. You can use for. You see. Okay, good. Folks, in case you have any other questions, please email me. Or I don't know, just contact me somehow. I have some here. Email. Please don't hesitate, okay? The best way to reach me is via Twitter, if you want. But
okay, we have a question. Does Codota use a connection for completion?
No, it's disconnected. There is a way to connect it to somewhere, but I use it. Interesting. I think it downloads every now and then the completions. How Codota really works is they've indexed the code on GitHub in hundreds of open source projects, and they are suggesting you the stuff which are typically looked for when you. But I think it uses a connection, but every now and then, if I disconnect my internet now, but I will not, it will still work. That's for sure. I used it on the plane, and it still works.
Okay, great.
Other questions? Come on. If I don't want to get over the time frame of the next speaker, so please reach me out if you have any other questions. And yeah.
Okay, let's wait a bit, please.
Yes, sure.
Okay. What do you think about VS Code?
Now, if you are writing code in many languages like Java, maybe a bit of SQL, maybe a bit of JavaScript and a bit of web, then for sure I would recommend WebStorm for your writing JavaScript. But in case you are not a full stack or if you are just writing JavaScript, then Visual Studio Code is more lightweight, I would say. Easier to learn at the beginning. But if you are writing code in many languages during the same day, the advantage of using IntelliJ everywhere or JetBrains everywhere is that you can use the same key map, right? Very helpful. Plus, but the problem is the WebStorm is on money. You have to pay for it. That's a big problem. But for Visual Studio Code, yeah, so Visual Studio Code highly tuned with plugins is very good. It's very good. I don't know, 60, 70% of what WebStorm will give you in my and others' experience. But it's good. Visual Studio Code is super good. It's already very, very good indeed. Other stuff?
Okay, that's everything for the moment. If you have any questions, you have Victor's email, so you can contact him there. Thank you very much, Victor. Let's get to our second and last keynote from today. Cleaner Code. The speaker is Tai Van de Ven. And Tai began his career mostly working on fixing bugs in a big monolithic application. This made him passionate about exploring concepts and ways to code to prevent bugs from ever occurring. He embraces this passion in his daily life by helping companies with architecture, programming, and training as a software consultant for JDriven. So the floor is yours.
Okay, can you all hear me and see my screen? Good, thank you. Welcome to my talk about Cleaner Code. Before I go talk into the subject, I would first like to introduce myself a bit. So my name is Ties van de Ven. I'm 33 years old and I'm from a country called the Netherlands. Currently, unfortunately, remote because of the whole Corona situation. And if I'm not programming in my spare time, I like to do some bouldering or also some top rope climbing, which is very fun, but in a way also a bit ironic since my country doesn't have any mountains at all. If I'm not doing my day-to-day job as a software consultant, I'm also quite involved in sharing knowledge. And I do this in multiple ways. I give trainings to certain companies. I do some individual coaching of people. I go to conferences like this. And I also give workshops for JCore, our daughter company, which turns junior programmers into senior programmers. And one of the courses I'm giving there is Clean Code. And I've been doing that for quite a few years right now. And basically, I'm doing it different now than I was 5 years ago. And that's what I want to talk about today, the things I learned over the few years of, first of all, real-world experience, and also giving the Clean Code course. So the biggest problems I encountered in the field are that there are way too many dogmas out there about Clean Code. And also that during code reviews, people talk about the wrong things, in my personal opinion. So those are things I would like to address today. What are the dogmas? Let's try to go beyond the dogmas. What are all these dogmas trying to achieve? And also, what are, in my opinion, the right things to talk about during a code review? So let's start off with part one, the dogmas. So according to the Oxford Dictionary, a dogma is stated as being a principle or set of principles laid down by an authority figure as incontrovertibly true, which in practice basically means that at some point in his or her career, a programmer learns a certain sentence about, for example, about Clean Code, and lives by that sentence, instead of actually thinking, why is this sentence there in the first place? To give you an example of, in my experience, quite a popular dogma is should a function have one return statement or multiple return statements? And I'm in the camp of multiple return statements, so I think the bottom code is better than the top code. And every time I come in a new team, I basically have to have this discussion with at least one other person. And if someone's in the one return statement camp, that person usually comes up with the single entry, single exit principle of Dijkstra. And this principle is quite true, but it was only true in languages which use go-to statements, because that was the time when Dijkstra said this. If you have to jump into a function, you should always go to the first line of the function, as in a function should always have a single entry point. And when jumping out of the function, you should always return to the same place. It should have a single exit point. So this argument, it's a great argument, but only for languages which use go-to statements. If your language has functions, this problem has been solved. So please, for the love of God, next time, if you're ever in a discussion with about multiple return statements, if you're in the single return statement camp, stop bringing up this argument, because it's not about this. But it's a good example of one of the many dogmas that are out there. So within clean code, I found a few small dogmas and a few big dogmas. And I'd like to start with the small dogmas first. And those are things like using constants, naming, making SonarQube happy. And these usually translate into the following code review comments that I've seen quite a lot. That, oh, you should put that string into a constant because you use it multiple times. Oh, you should change that variable name. Or you should make that user class final because it contains only static methods, and that's how Sonar would like it. And these are all not inherently bad things, but are they really that important? And to that I say, well, up to a certain degree, these things are important. But are they really that important? Well, no, because if after the code review, I can fix these in about 2 minutes. And if I would spend 2 more years working on this project, adding heaps more code to it, adding heaps more complexity to it, all these things still probably only take 2 minutes to fix. We just seen in our talk how easy IntelliJ can change these kinds of things. With your IDE can change a variable name or put a string to a constant in 2 minutes, even after 2 years. So actually, putting a string into a constant doesn't really have that much effect on your application in the long term. So these things, although they're important to a certain degree, these should not be the main focus of your code reviews. To give you a bit of an example of what would be a good thing to focus your code reviews on is if a function returns null. Because if one function returns null, the caller of that function now has to take into account the first function returns null. So that function will probably also return null in that case. But now all the callers of that function also has to take into account this function returns null. So it will probably return null itself in that case. Now the function calling that function, well, you can basically see where this is going. And the Hindus have a very good saying about this, which is turtles all the way down. Basically, if one function starts returning null, it's null all the way down in your application. And after 2 years after introducing this won't take 2 minutes to fix. This may take hours or even days to fix in your entire code base. So all these small things, they are important, but things like this actually has a much bigger impact on the long-term maintainability of your code. So we also found some big dogmas out there. And a few big dogmas I discovered are avoiding duplication at all costs, that functions should be small, and that code should be easy to read. So let's dive a bit into those. Avoiding duplication. Basically, every programmer learns quite early in their career that duplicate code is bad code. You shouldn't have duplicate code. And while this is true to a certain degree, I found another statement on the internet at some point that changed my mind a bit about this. And that is, duplication is far cheaper than the wrong abstraction. And the key part in this sentence is the wrong abstraction. Because code that is incredibly similar doesn't actually have to be duplicate. If code is 99.9% the same, it might not actually be duplicate code. Or two code paths which are the same now, it can be diverse again in the future. To give a bit of an example of this, our programmer finds 3 different code flows, code flow 1, 2, and 3, and it says, oh, well, this is basically the same code, so what should I do? I should write an abstraction for it. Great, now we only have 1 function instead of 3. But then the programmer finds out, oh, in code flow 1, there's actually 1 special case that doesn't happen in the other 2 code flows. So what happens now? The programmer starts adding a Boolean. And now in the code flow, the abstraction also supports code flow 1. Okay, 2 months later in the project, it turns out that code flow 2 also has just a small thing slightly different from the other two. So what happens? Our programmer adds another boolean. And you can see where this is going. If the code paths, if the functions you're trying to abstract are not completely the same, are full duplicates, what we get now is instead of having 3 very simple flows, we now have 1 very complex flow with multiple branches in it. So if you ever try to deduplicate code, make abstractions, and you find yourself adding Boolean flags to it, that might be a big red flag to see, well, maybe those code paths were actually different things instead of the same. The second dogma I encounter is that functions should be small. Again, basically, small functions are a good thing. The problem I have with this dogma is that implementation matters a lot in this case. To give an example again, a programmer sees our function f1 and it sees, oh, that's a really long function. Oh, let's split it up into smaller functions. So he defines 2 other functions and calls those from f1. In this case, I didn't define the extra functions separately because that will just take up a lot of space in the slide. But f1 now calls f2 and then calls f3. Well, this is still good. But then it turns out that f2 and f3 are actually still quite long functions. So what does our programmer do now? Well, long functions aren't allowed, so let's split those functions up again. And now things get a bit fuzzy, because if I'm trying to find the code flow now, I mentally have to take quite a few steps. Because first I come into f1, I see 2 function calls, f2 and f3. In order to find out what f2 actually does, I need to go into f2. Then I see another 2 function calls, f2a and f2c. When I go in f2a, I see another function call, f2b. So in order for me to understand the code flow, I basically need to jump forward and back all the time, always mentally keeping track of all those things. And this can become quite difficult indeed. And the problem here is not that the functions are small. The problem here is that the functions don't do one thing. f1 basically does all this stuff. But f2 doesn't only do f2 things. f2 does f2 things, f2a things, f2b things, and f2c things. So creating smaller functions are a good thing, but by doing it like this, you basically create a very complex code flow. Luckily, the solution for this is actually quite simple. Start making lots of small functions, but just call them in order, one by one. And start to make sure that the indentation of the function remains quite low. This way, you have all the benefits of having small functions, and it's still extremely easy to actually read the code flow in your code. So small functions are great, but don't make functions call functions call functions call functions call functions, because then it becomes basically impossible to read. And this is something I encounter a lot in my work. The last dogma I encounter a lot basically is that code should be easy to read. And this is basically the thing that when I talk to people about clean code, most people will say, oh, you do clean code because that makes code easier to read. And I disagree with this. And mostly I disagree with the word easy, because this is not a good metric to measure code by, because easy is extremely subjective. Something you find easy might be very hard for me, and vice versa. To give an example, if one of your team members never used a for loop in his or her life, only used while loops, and you start using a for loop in your code, your team member will say that your code is hard to read, just because that person is not familiar with a certain concept. So having code that's easy to read, actually, in my opinion, leads to the wrong discussions, because you basically start discussing about which structures you're allowed to use within your code. And basically, you have to adapt your whole team to the least experienced and least knowledgeable person in your team. And in my opinion, these are not the good discussions to have. So instead of saying code should be easy to read, I would instead suggest that code should be simple to read. And it seems like a minor difference, but it's actually quite a big one. And that's what we're going to talk about in part 2, trying to go beyond these dogmas. What are they trying to achieve? So what is the difference between simple and easy? Well, I'm going to steal a bit of explanation from another talk I once saw, which is Simple Made Easy by Rich Hickey. After this talk, I would definitely encourage you to watch that talk. It kind of changed a lot of my way of thinking about code. So Simple Made Easy by Rich Hickey. So the difference between simple and easy is that easy is an easy versus hard discussion, and simple is a simple versus complex discussion. And easy here is, in this case, something that is close at hand, as in something you already know or something you already have. For example, if I need to make a new microservice, it's very easy for me to do that in Spring Boot because I'm very familiar with Spring Boot, so it's easy for me to do. Is it the best solution? I don't know, but it's an easy solution. Same with any tooling you got already installed. If you installed a certain tooling and it's easier to use that, then install a new tooling and find out how that works. As in, if you're used to Eclipse, then it's easy to use Eclipse and hard to use IntelliJ. Unless you made the switch after 13 years, then at some point, IntelliJ also becomes easy. So this is easy versus hard. Simple versus complex is a bit more of an abstract thing, but it's quite well visualized in pictures. Where complex means to complex something, which means to tangle it up. And we can see that on the picture on the right here, where we see a bunch of power lines where we basically have no clue which line is connected to which other line. While on the left, we see a power pole, where it's very easy to see which power line is connected to which other power line. So the right one is complex because it's all tangled up, and the left one is simple because it's very easy to see which line goes where. And having an application that is simple has quite a few benefits. For long-term maintainability, it's a lot easier to add and change features to an application that is simple. Also, finding out the code flow is a lot easier in a simple application than in a complex application. As in, I would much rather work on the left picture than on the right application that looks like the left picture than an application that looks like the right picture. And basically, if you try to look at all those clean code rules you ever learned, in one way or another, what they all have in common is they all try to decrease the complexity of your application, to make your application more simple. So instead of learning all those rules, I would like to suggest that this is a good alternative viewpoint towards code quality. Stop thinking in rules and start thinking in complexity. Because simple code is usually, in almost all cases, high quality code. And using simple as a metric instead of easy is a lot better, because simple is a lot more measurable than easy, because easy is different from each person, while something being simple is more of a mathematical thing. And also, once you start talking about solutions and you try to see which is the simplest solution, then you're, in my opinion, having the right discussions, having very valuable discussions which will increase the quality of your code. And that brings us to part 3. So what are the right things to talk about during either a code review or sometimes even before starting to code? Linus once said, had a very good quote about this, and that is, bad programmers worry about the code and good programmers worry about data structures and their relationships. And what he basically means is that the structure of a program is a lot more important than the actual implementation. If you have a very well-defined program with a great structure, the actual code is basically just a minor implementation detail. So how do we get our program well structured? Well, to be honest, I found out that's mostly functional programming stuff. And I also have an hour talk about this, where I go deep into these functional programming things. But we basically only have 15 minutes left, so that's not going to fit. So instead, I'm trying to give you a few highlights of that talk. So we're going to talk a bit about function signatures, about managing state, and about managing side effects. So function signatures. A good function signature helps a lot with the ease of use of any function and the ease of reuse of any function. And a function signature is defined as is a sort of notation, basically, where it says input, arrow, output. So in this case, the function signature would be given an int, produce a string. So int to string. This is actually also a very good trick to think about your functions in a very abstract way, just seeing input to output. To give you an example of that function signatures can actually affect the reusability of your code. If we take the top function signature, it's array list to array list, which means that this function can only be used with an array list. A lot better function signature would be list to list, which means that not only you can use it with array list, because array list is an implementation of list, you can also use it with a linked list or even your own implementation of the list interface. So having a good function signature makes a function a lot easier to use and to reuse. More importantly, actually, is that function signatures can also lie to you. In the top function signature, we will see that the signature says, given two doubles, return a double. But what the function actually does is, given two doubles, return a double, or kill your current thread. But because killing the current thread is what a runtime exception does. And basically, the only way to know that this function kills your current thread is by reading the documentation, which of course everybody always does, if the documentation is present at all, which of course every function is well documented. And if neither of those are the case, then, well, hopefully you will have access to the source, or else you'll have a very nasty surprise at runtime at some point. The same goes for the bottom function, where again the function signature is given two doubles, return a double, but actually, instead of returning a double, it will return null, which is a very nasty value, because in a way it's everything, including a double. But it will cause a null pointer exception somewhere down the line. And again, your function signature doesn't protect you from this. You can only see this is happening by either reading the documentation or see the implementation. So luckily, since Java 8, we now have a way to make this work. Because in Java 8, we got the optional data type, where an optional is either empty or it has a value. So by using this as a return type, our function signature suddenly becomes, given two doubles, I might return a double. So my function signature suddenly becomes honest about its behavior. It can either go right, and then you have a double, or it can go wrong, and then you will have an empty result. But at least it's honest about what it does. Not only that, by returning an optional, something else happens. Because before, the function itself was deciding what should happen in a fault case, as in it should kill the current thread or it should return a default value. But what you actually want to be happening can be different for each context you're calling that function from. And this is where an optional shines as well, because an optional has a few methods which allow you to define what should happen in case of an error. For example, you can return a default value, or you can throw that exception if you like. But the difference is that instead of the function deciding that, now the caller of the function decides what should happen in case something goes wrong. And the caller of the function usually has a lot more context than the actual function you're calling. So this is a good thing. So during your code review, I would say try to pay a bit of attention to function signatures. Try to make sure they're easy to use, and if they're lying to you, as in throw an exception or return null, you might want to consider looking at the optional data type in order to prevent this. The second big subject is managing state. And this is something I talk about a lot. And I can talk about this for a very long time. I should keep it as short as possible right now, though, because state is the main cause of bugs everywhere. Like by far, most bugs you ever encountered are because of state management, or mostly bad state management. To give an example, if you ever fixed something in one part of an application and another part breaks because of that, that's basically a state-related issue. If you ever fixed anything in your life by turning it off and on again, that's probably you had a state-related issue there. And having a bad state management can also lead to quite complex flows in your code. Luckily, it's quite easy to actually prevent all this from happening, and that's making all your variables final and remove all the getters from your objects. Well, in Java, this is not entirely true, but it's quite close. Especially if you get to collections, it gets a bit more fuzzy. And if you do this, suddenly state changes become a lot more explicit. But if you no longer have setters on your objects, you might ask yourself, so how can I change the state of my objects then? Well, actually, that's quite easy. Instead of changing a field in the object, instead you return a new object with the updated state. So changing the age of the person, increasing the age of the person by 1, instead of editing a field, you return a new person where the age has been increased. And if you do this everywhere in your code, a few things start to happen. First of all, state changes in your code become very explicit. For example, in the top example, we have no clue what do something does. Will the first system.out print line print the same as the second? Basically, we have no way of knowing unless we actually go into do something. If person, however, would be immutable, so it has no setters, do something can't change that object. The only way for it to cause a state change is to return a new version of person. So now I can easily see a state change is happening in there because I get an object returned from the function. And now, as a programmer, I can choose, do I want to use the old state or do I want to use the new state? But state transitions are suddenly, instead of magically happening or not, we have no clue, become a very conscious decision. So you are forced to think about state changes within your application. Another anti-pattern which gets solved by having immutable objects is what I call setter hell. And I've encountered this quite a bit in a few monoliths I worked on, where at some point you will create an object, and over the course of a whole function flow with the functions calling each other, that object will get enriched with setters. And the big problem I have with this is that you basically have no clue at what point the person is in a valid state. Because basically person is only in a valid state if all the setters have been called. So in this case, before calling the bar method, person is not in a valid state because it has no age yet. And only after calling the bar method, the person gets into a correct state. Having immutability basically makes this impossible because you now have to supply all the things, all your arguments to the constructor. This also makes sure that if you want to add an extra field, you don't have to remember to put in setters everywhere because you will now get a compilation error because your constructor has one fewer parameter than it needs more parameters than you already have. And if you have to supply everything in the constructor, that actually gives you a third good pattern in your code. Because in order to create an object, you'll first have to gather all the information, then do sanity checks, and only then you can create your object and continue. And for me, this is actually quite a very logical, well-defined flow that I would like to see. This is for me very easy to read. Collect information, do sanity checks, proceed. And because of immutability, this becomes a more natural thing for your code to do, because basically anything else becomes impossible to do. And those are the kind of things I like. Instead of fixing symptoms, try to fix the problems. How can I prevent something from ever occurring instead of trying to fix a problem? The last thing I want to talk about is managing side effects. Because if you manage side effects correctly, functions become a lot more reusable and function becomes a lot more testable. And also, if you're, you can get the slides later. Also, if you struggle with splitting up a function into smaller functions, this is a very good metric to help you with that. So what are side effects? Side effects are basically anything that either changes state or uses mutable state from outside a function. And these are things like setters, because a setter changes a value outside of its function, but also things like any form of I/O, like database access, file access, accessing a web service, or even logging, because that writes something to standard out and might be put into a file at some point. And the thing I don't like about side effects is that they prevent functions from being deterministic. As in, because of these things, the behavior of a function becomes basically unknown. You never know how this function will behave at any point in time. To give an example, if a function does a database call, that function may either return a result because the database had a record, it may return no result because the record couldn't be found, or the function throws a runtime exception because the database connection dropped. So basically, at no point in time, we know how that function will behave. And this is generally a bad thing. To put that into a small example, here we have a function that finds a user in the database, then does some silly business logic, and then stores that person into a database again. And the big problem with this function is that in order to test this function, we first need to have a database or even an in-memory database just to test this function. Also, if we now want to reuse this function, we also get the database actions there for free, as in it's for free, but it's usually probably not something you want to have. So how would our function look like if we would separate the main code from the side effects? It would look something like this. So the function foo still has side effects because it has two database calls. But the function do business logic is now free of side effects. It only does one thing, and this thing can only go right. It's very reliable. Also, it's now a lot more testable than the previous solution, because you no longer need the database to test our business logic. And if you want to reuse that business logic, again, it's easier because you no longer have the database calls. So separating your business logic from side effects makes your code a lot more testable and a lot more reusable. And if your function contains no side effects, that's what we call a pure function. And all these functional programming things, well, in my opinion, they're quite hard, at least at first. I started programming in this style about 3 to 4 years ago, and I'm still learning new ways. I'm still getting better grasp of all these concepts. So this is quite a hard road. But then again, making something very simple is a very hard thing to do indeed. But at least there's a little bit of solace in there, because if you practice doing things simple enough, eventually simple becomes easy. And with that, I would like to close my keynote. If you'd like to talk more about this subject, because I find it very interesting, feel free to contact me on Twitter, LinkedIn, by email, or talk to me in real life. Same goes for if you're now starting to get an interest into functional programming and would like to hear my 1 hour talk about this, just contact me and or ask me some questions now. So thank you very much for listening and for having me here.
Thank you very much, Tai. It was a great presentation, and the audience thinks the same. There is someone who asked if they can have these slides.
Can I send them to you? Or, well, they're also available on this URL.
Yeah, you can copy and paste on the chat,
Yeah.
and I think it's okay. Great.
They're available on the URL. If you you can also turn this into a PDF by putting this afterwards, and then send it to printer and then export it to PDF using that way.
And we have a question. Do you have a reference point Dragoș could use for your argument on single exit point? Sorry.
What do you mean? My point was that single entry, single exit was I meant for languages that use GoTo. If your languages contain functions, this statement doesn't apply. So if you use GoTo statements, then this is a good thing. If you don't use GoTo statements, it doesn't apply to you. I don't know if I answer your question with that.
Let's wait for some details from him.
Google. Basically, if you Google that sentence, there's a Stack Overflow post which explains this quite well, and there are numerous other sources which explain this quite well.
He said that he did that a while back and it was quite in between.
I don't have a direct source for that from the top of my head. If you're very interesting, send me a message on Twitter. I'll try to find a better source for you. It doesn't seem good that I'm Googling that right now live. That's not going to go well. Also, although I found the point about single return statements versus multiple return statements a very interesting discussion, that was actually not the main goal of this whole presentation.
In the same time, Rami said that he thinks multiple exit points functions make it easier to ignore the cases that we're not interested in it.
Exactly. Yeah.
It also makes
basically
sense for the cases that you don't need.
Yeah, I agree. Like basically, I have a few good arguments for multiple return statements. If you're basically, it's for me, it's easier for debugging. It's easier for me to understand the flow, and it's also a lot shorter. But again, I rather talk about clean code and complexity and functional programming things now than having that discussion live.
Oh, we have some people typing now. Let's wait a bit.
When to use an abstraction or interface? Well, using interface is generally good, although, again, abstractions are in the form that seeing two code paths and try to create one function which contains those two both my code paths is an abstraction. Usually try to see if they are really duplicate, and sometimes it's like even if you have two of these, that doesn't mean you don't know if it's ready for an abstraction yet. Maybe if you do the same thing 3 times, you might think, oh, this might actually be a duplicate thing. Let's make an abstraction from it. And also, if you find out you're adding Boolean flags, you might want to return it back to the old situation.
Is solid principle relevant still with microservices?
I would say, yeah, but I look at microservices in a bit of a different way. A guy called Simon Brown once gave me a very good talk about that, and I quite agree with him. I don't see microservices as basically a new thing. I just see components, and microservices are an implementation of a component architecture. It is, maybe I can get to a different approach in this question, as in, if your code base is really small, do you still need to have clean code? Maybe that's your question? Because if that's the case, basically the goal of clean code and any functional programming things are to reduce local complexity. And if your complexity is already really low, as in because you only have like 50 lines of code, a lot of things actually don't matter that much. If your microservice is only 2 classes and there are only a few lines in each class, hey, clean code isn't that important.
Okay, he said that what happens is that they are abstracting to common classes and including as a common jar in microservices.
Yeah. That's, well, that depends on what kind of code it is. In microservices, it's fine to have duplicate code. Also, if you it depends on what it is that you're sharing. If it's, because if you're sharing too much between 2 or 3 microservices, for example, that might also be a conclusion that they shouldn't be separate microservices because they share a lot of code. If it's things like security library or general logging solutions or something, this is fine.
They share entity objects.
If they share entity objects, actual database entity objects, then I would probably consider putting them into the same service and still have them as separate components just in one deployable, because they might share too much, basically. If they're domain objects, then there's a case to be made for this. Also, the Hoeveel says something about for performance point, which is fast. By the way, I hope I answered your question about share the entity objects.
So it seems.
Okay.
Let's wait and see if someone else has anything.
Yeah, for performance point, which is fast, was also a question I see. And to be honest, first of all, I don't really think about performance that much because usually premature optimization is the root of all evil. As in, only if performance becomes a bottleneck, then I will try to look at performance. But as long as it's not a bottleneck, I prefer to make the code as simple as possible. That being said, okay, if performance becomes an issue at some point, I will try to locate the biggest bottleneck. And for example, if that would be, I need to iterate over 1 million times over something, and each time I need to, for example, where string builder was for. Instead of appending a string and creating a whole bunch of new objects, with the string builder, you basically use mutable state. But what I'll then try to do is try to encapsulate this as much as possible. So my incoming object will be immutable. My component will do some mutable state in between, and my output of my component will also be immutable. So this way I can still have immutability for the rest of my application, but still use mutable state for performance enhancing reasons. But again, I will usually think about performance only if my application doesn't actually perform well. And in practice, I don't notice that much difference.
Okay, thank you very much. I guess there's no one else having questions at the moment. Those being said, thank you very much.
That was nice for you to have me here.
Wait a bit, there's someone typing. let's see some. Okay. Andrea, someone raised their hand. Could you give them access, please?
Rami, I gave you access. Now you need to unmute yourself by using the microphone. Okay.
Can you hear me?
Yeah.
Yes.
Okay, great. So yeah, I wanted to come back to the question regarding the when to use abstractization or interfaces.
Yeah.
So I have a rule that I'm trying to apply it in most of my coding. So when I try to apply abstractization is when I try to change a behavior of some objects that use similar or identical behavior. Whenever I try to expose something to an entity like an IO, like you said, something that changes the state of the components, then I try to use interfaces. I only let the input of the application coming from interfaces point of view, and everything else that builds, and I'm trying to change the behavior of any objects, then I use abstractization.
Do you have a question in that, or is it for
No,
discussion?
it was just for discussion purposes, yes.
Not 100% sure I understand you, but you use interfaces for incoming objects, as in every component has an interface?
That's, yeah, exactly.
Yeah.
Every component should have an interface that communicates with the outside world.
Yeah. And well, in this case, well, there's an interface as an API and Java interface. In this case, I use it. I try to think in components, and the components, in my opinion, is everything which has an interface and returns something. So a function can be a component, a class is actually a component, and a component can also contain multiple components. And that's, for me, a very good abstract way of thinking about things, as in I put something in this component and I get something out from this component. And the rest of the world should only know that interface and never anything behind it. And that's the power of encapsulation.
Yeah, thank you.
And that's why I think microservices are just components, nothing more. And there's no shame in having one microservices with 3 or 4 components. Just make sure they're separate components and they could be deployed as several microservices. But it's totally fine as long as you have a component architecture. Monoliths are amazing. I like stateless monoliths as well.
Okay. Those being said, in the end, I would like to remind you about the feedback. You can find it on top of the screen right now. Please fill in. Also, thank you very much for your presence, for your attendance, for your questions and discussions. I hope it was a really good conference for you, and you learned a lot of new stuff. I wish you a great evening and see you soon.
Thank you very much for hosting me, and I enjoyed it all. Thank you.
Thank you. Bye.
Goodbye.